Hi there, and welcome to Mrs. Nelson Science. This is lesson 2 on how to draw atoms. If you haven't filled in your terms to know on pages 3 and 4 in your booklets, we just have one term to know today. That term is valence or valence electrons. Those phrases are often used interchangeably. So valence electrons are the outside shell of electrons that surround the nucleus of an atom, or the outermost electrons. I'd also like you to take a second and review the terms from last class. If you need to pause the video while you copy it down, go ahead and do so now, and you can unpause it when you're done with the terms. So we're going to draw a Bohr model of an atom, and there's many different versions or models of the atom, but the one we're going to learn in grade 9 science is how to draw a Bohr model of an atom. We're going to have 4 steps to drawing a Bohr model, and we're going to use fluorine as an example to help us understand what those steps mean. So step 1, we're going to determine the number of subatomic particles found in the element. So subatomic particles are those protons, neutrons, and electrons. So you need to remember from lesson 1 how we find the number of protons, how we find the number of electrons, and how we calculate the number of neutrons. So in order to do this, we're going to need to determine the number of neutrons, protons, and electrons in each atom, or in each element. So up in the top right corner, up here, just circling it, I've given you kind of what the square on the periodic table would look like for fluorine. So the atomic number for fluorine is 9, that's that top number. The atomic mass for fluorine is 19, that's that bottom number. So you need to remember these formulas I've got written down here in red. The atomic number is equal to the number of protons. So for fluorine, our atomic number is 9. So we've got 9 protons. In a neutral atom, the number of electrons will equal the number of protons. So if the positive and negative charges kind of all cancel each other out and the atom has no overall charge, that's a neutral atom. So if we have 9 protons, we're also going to have 9 electrons. So the number of electrons will also be 9. In order to find the mass, if you remember from lesson 1, here's where we need to do a little bit of math. The mass is going to be, the number of neutrons will be equal to the mass, that bottom number. So in fluorine's case, it's 19, minus the top number, which is 9, or that atomic number. So if we do 19 minus 9, we get 10 neutrons. So for the mass, I've given the formula to you as mass minus protons equals the number of neutrons. If you want to remember that it's the bottom number minus the top, that's fine. The big number minus the small, that's okay too. Whichever one makes the most sense to you is the one you can work with, but just remember that we've got to do a little bit of math to find the number of neutrons. So step 2, we draw the circular nucleus. So here's my circular nucleus, it's drawn in blue. And then inside the nucleus, we need to indicate how many protons and how many neutrons we have. Okay, so for this one, for fluorine in step 1, we found that there was 9 protons and 10 neutrons. So I've indicated them inside that circle, that's my nucleus. Step 3, we have to draw the correct number of electron shells or rings. So if you need to know how many electron shells there are, you're going to look on the periodic table, the one in the back of your booklet or the front of your booklet, and you're going to look at what row, which is called a period on the periodic table, what row that particular element is in. So row 1 or period 1 just contains hydrogen and helium. Row 2 starts with lithium and it ends with neon, but if we look really closely in that tall column 7, we're going to find fluorine is there. So fluorine is found in period 2, row 2, so it's going to have 2 electron shells. So this first circle is our nucleus. It's containing our protons and neutrons. And then there we've got our 2 electron shells. So step 4, we have to put electrons in those electron shells. So step 4, we need to represent the electrons, and we usually do this as dots. Sometimes we'll use little e's with a negative sign, and position the electrons in those orbits or those energy levels or those electron shells, whatever we're calling that. So we have to fill the orbit with the lowest energy first. So that's the shell closest to the nucleus. That first shell is the smallest one, so it can only hold 2 electrons. Once it's filled to the maximum, the electrons will start to fill that second ring, which can hold a maximum of 8. And when that one's full, it'll work on that third ring, or that third shell, that can also hold a maximum of 8. So we start closest to the nucleus and we work our way out. Once the electron shells are full, we move on to the next ring. So the electrons should kind of be equally and symmetrically distributed throughout, although you're going to see me sometimes kind of pair them up because it makes it a little easier to know whether you've got the correct number of electrons or not. And again, those valence electrons are those outermost shell of electrons. So the way we use that valence electrons is the valence electrons are going to be the same as the tall column number. So since fluorine is in tall column, if we only look at the tall columns on the periodic table, tall column 7 is going to have 7 electrons in the outer shell. So we have 9 electrons to fit for fluorine. 2 are going to fit in the first shell. Then we have 7 left to place. That second ring can hold a maximum of 8, so all 7 would fit in that third shell. Or sorry, second shell, second ring. So let's do an example together. So we're going to do the example of sodium. So what I'd like you to do is pause the video and turn to the back of your booklet and find that periodic table and see how far you can get in there. I've given you kind of little shaded in dots where you might want to place the electron, but in that first ring I had an extra dot and I didn't realize it when I photocopied your book. So if you can just kind of give that one an X out, that would be great. So pause the video and try sodium. Now that you've had a chance to try sodium, I'm going to go through it together with you at this point. So sodium, the symbol for sodium is Na. So it's always a capital N, and then if there's a second letter, it's always a lowercase. The atomic number for sodium, if we find it, and sometimes the hardest part when we're starting to learn chemistry is just locating those elements on the periodic table, but we'll get used to it and you'll get faster at it. So the atomic number is 11. The bottom number is 23. So our atomic number is equal to the protons, and the protons equal the electrons. So if this is 11, this is also going to be 11, and this is going to be 11. So the first thing, our step 1, is to find how many protons, electrons, and neutrons you have. Remember, the neutrons, we have to do a little bit of math. We take 23, our mass, and we subtract off those number of protons, so we get 12 neutrons. Step 2, we needed to draw our nucleus, which I've drawn for you, and we needed to put in the protons, which equal 11, and the neutrons, which would be 12. And I've written them a little bit different, and you're welcome to write them either way. Step 3, you're going to draw your rings. So I've already drawn the rings for you. We're just going to shade in those dots. In the future, you'll only draw the rings you need and the dots for the electrons that are present. I have 11 electrons to place. Remember, 2 can fit in that first shell. 1, 2. Once that's full, I'm going to move on to the next ring. I have 9 electrons left. That ring can only hold a maximum of 8, so I'm going to shade in all 8. And I still have 1 more to place, so that 11th electron is going to go in that third shell. Remember, a quick check, if sodium is in tall column 1, it should have 1 electron in the outermost shell, and it has that. I did it for you here. There we go again. Okay, let's do chlorine together. So if you can pause the video and get out your periodic table and try chlorine on your own right now. Now that you've had a chance to try chlorine on your own, let's do it together. So chlorine, the symbol Cl. Again, you're finding this on the periodic table. The atomic number, that's the top number, it's 17. The bottom number is 35. Once we know that our atomic number is 17, we know the number of protons will be 17, and the electrons will be 17 as well. To find the number of neutrons, we need to do a little math. 35 minus 17, so we have 18 neutrons. That was step 1, was finding the protons, electrons, and neutrons. Step 2 is to draw our nucleus and put in the number of protons and neutrons, which is 17 protons and 18 neutrons. Now we need to draw the correct number of rings. Chlorine's in row 3 or period 3 on our periodic table. It's going to have 3 electron shells or 3 rings, which have already been drawn in for you. Now we need to shade in the dots. We have 17 electrons to place. So we're going to put 1, 2 in the first shell. Now it's full. That first shell only holds a maximum of 2. Again, I had a little typo on that first page, so if you can make sure that that one kind of gradient dot is crossed off, it shouldn't be there. Once that first ring is full, we're going to move to the second ring. It can hold a maximum of 8. So there we are, 1, 2, 3, 4, 5, 6, 7, 8. That accounts for 10 of our 17 electrons. We still have 7 more to place. They'll fit in that outer ring because it holds a maximum of 8. And there's our 7. Our quick check, chlorine is in tall column 7, so it has 7 electrons in the outer shell. I hope this is helpful. We'll see you in class tomorrow where we'll practice and do some more examples on this. Thanks very much.